Hello, everyone, and welcome to the monthly Intermountain West Regional Drought Early Warning System webinar with the National Integrated Drought Information System, or NIDIS. I'm Gretel Fallingstad, and I am the Intermountain West Drought Early Warning System Coordinator for the Intermountain West and the National Drought Planning Program Manager for NIDIS. These Intermountain West monthly webinars are drought briefings in partnership with all 5 states of the IMW or Intermountain West region, which include Arizona, New Mexico, Colorado, Utah, and Wyoming. We aim to provide drought conditions and monitoring and reporting to increase landscape and community resilience in both current and future drought. The IMW DEWS region also has partnered with other federal agencies on special topics or projects related to drought and drought early warning, including the National Drought Mitigation Center, USDA's Climate Hubs, the USGS, and others. Currently, across the Intermountain West, Arizona has about 54.6% of the state in drought, Colorado 11.7%, New Mexico at 88.2%, Utah at 3.8%, and Wyoming at 21.7%. And in today's webinar, we will hear more about those conditions from Tony Anderson, who has been with the National Weather Service in Cheyenne, Wyoming for 21 years and is currently the Senior Service Hydrologist at the National Weather Service Forecast Office in Cheyenne. We will also hear from Tony Bergantino, who will give us an overview of Wyoming's Water and Climate Explorer dashboard. Tony is the director of the Wyoming State Climate Office and Water Resources Data System, where he has worked for the last 30 years. In addition to drought, 2 very related research interests of his are snow hydrology and consumptive use of water. Then we will hear from Wendy Kelley, who has worked for the University of Wyoming Extension for over 11 years. The first 2 years she served as the Rangeland Extension Educator, and the last 9 years she has served as the Regional Extension Program Coordinator for the USDA Northern Plains Climate Hub, serving the 6-state region. NIDIS has a snow drought update that comes out periodically through the winter, and our latest snow drought update of February 2024 is available on drought.gov. And here is a flash of that snow drought update if you are interested in taking a look. We have seen improvement in the lower portion of the Intermountain West, and as you can see, the northern portion of the west, near the Canadian border, is still suffering from snow drought. So next we will hear from Tony Anderson on drought conditions. Tony, are you able to unmute?
I am. Can you hear me?
We can, thank you.
Great. Okay, I believe it's afternoon for everybody, so I'll say good afternoon. And I just want to take, as Gretel said, I am the service hydrologist at the Cheyenne office of the National Weather Service, and I'm just going to take you through some of the drought data that we analyze, especially Tony Bergantino and I, and Wendy on a week-to-week basis, except we're going to do it for the entire Mountain West instead of the state of Wyoming. We're going to look at temperatures and precipitation, okay, and snowpack development, our current drought status. We're going to look a little bit at our water supply standing, and then look at our outlook. That drought status got duplicated there. We're going to look at some outlooks over what the next 2 or 3 months may hold. So go ahead, next slide. And again. Okay, the top row of graphics here is an analysis of the last 20 or 12 months of precipitation and temperatures across the entire United States. In the lower section, it is just this winter, so November, December, and January. And they tell very different stories. In looking at the whole year, the Intermountain West was dry, above average in 4 of the states, well above average in New Mexico. Or it was warmer, I should say. Looking at the precipitation on the right-hand side, a different kind of story. It was fairly normal in the north, slightly above normal in the in Wyoming itself, and then in Colorado and Utah, it was right around average or slightly above or slightly below. New Mexico and Arizona, it was below or just below average across that area. Looking at the winter, or just the winter, very dry and very warm. Wyoming's been remarkably warm this winter, and only one state, Arizona, is in the above normal or above average grouping. The other 3 are in the well above grouping for temperatures. And on the precipitation side, dry in the north. Wyoming is well above or well below normal. Arizona or Colorado and Utah are above normal, and then Arizona is in the normal category, and only New Mexico is sitting in the slightly above normal category. So very different stories for the last 12 months versus this winter. Generally speaking, it has been warm and it has been relatively dry. Next slide, please. Okay, same kind of information, I looked at it a different perspective. Looking at just the Intermountain area, almost all of it on the left-hand side is showing mean temperatures above normal or well above normal. There are some areas in eastern Colorado and northeastern New Mexico where we're showing normal numbers, and even in the Bighorn Basin of Wyoming. But generally speaking, the Intermountain West has been above normal to well above normal throughout the October through January timeframe. On the right-hand side, looking at precipitation, did pretty well in Wyoming until the tap turned off, but then in Colorado or Utah and Arizona, boy, I'm having trouble with states today. The above or below normal temperatures or precipitation has kicked in pretty hard. New Mexico is actually kind of right around normal, and Colorado is kind of a mixed bag, but probably leans towards below average. Next slide, please. Okay, looking at just the last 90 days of precipitation, so back to November of 2023 to just recently, the February 2nd, or excuse me, February 18th of 2024, paints a slightly different picture, and a lot of this has to do with the last 2 weeks. There have been large changes in our precipitation totals in the last couple of weeks. So all of those January data, all that data that stopped in January hasn't picked up on that, and so that's where we're seeing some of the differences here. You can see we've got lots of above normal, above average percents of normal in New Mexico, eastern Colorado. Wyoming's not doing quite as well. That northern range especially is in that well below or in the lower percentiles. Arizona has a big area of high percentile precipitation in the southern areas, and up in the Colorado River area and the Grand Canyon area, it dries out a little bit. Utah, more of a mixed bag. So it was mixed across the region, but we had some areas that got a lot of precipitation, especially in the last 2 weeks, and that pushed us into the higher percentiles. Next slide, please. This slide looks at snowpack from the National Weather Service no-risk office over at the current date last year and this year. So on the left-hand side is this year, on the right-hand side is last year. The big take-home message from this picture or these images is that there is a lot less snow this year than there was last year. And that is going to be reflected in some of the water supply numbers that we'll look at, or some of the graphics that we'll look at. It's pretty striking how different the 2 years are, and that's reflected in some of the maps we're going to see later in the basin by basin SNOWTEL or snow water equivalent analysis. Next slide, please. And here's one of those analyses. This is roughly the same data, except it's broken out by basin, and it's provided by the Natural Resource Conservation Service. And again, it is comparing February 18th of this year to February 18th of last year. And you can see there is a striking difference in the amount of snow that we have gotten and have stored in the mountains this year. The good news is that a lot of these basins in the last 2 weeks have come up from those orange and yellow colors and into the greens and light blues. So it's a much better looking map than it was 2 or 3 weeks ago. But that being said, last year we were doing better. So let's look at the drought. If you can go ahead, 2 slides. All right, this is the topic of the day. All of that information earlier was to show you how we got to this slide, drought in the Intermountain West. And it's kind of a mixed bag. Colorado and Utah are fairly stable right now. They seem to be taking as much as they're getting, and the drought conditions have pretty well stabilized. I have not seen their recommendations for this week, however. New Mexico is showing some minor improvement, but it remains deeply entrenched in the drought. Arizona, I have seen their recommendations for this week, and they're showing improvement in several large areas. So there's going to be some, hopefully, if the national compilers agree, there will be some large improvements in some of the areas in Arizona. Wyoming is again a mixed bag. In the south, we've shown some marked improvement in the last 2 weeks, and the drought we've seen a little improvement last week, and it's pretty stable this week. We're expecting a status quo designation in the south. In the north, the Bighorn Mountains are showing some real snow deficits. In the conversations I saw, someone mentioned that there is no snow below 8,000 feet in the Bighorn Mountains, which is, from what I understand, pretty much ridiculous for this time of year. And so that the Bighorn Mountains will be moving into D2 to match up with the Yellowstone area, which is already in D2. And it's been there for a while, so it's stabilized, but that northeastern section has shown degradation the last 2 weeks. Next slide, please. Okay, I thought we'd look at state by state, kind of the trends in the droughts over the history of the drought, and look at what we're seeing in the trends. And in this trend, it's hard to see. I may have to figure out how to shorten this so we don't get 20 years worth of data. But it looks like they kind of have stabilized, and with in Arizona, and it looks like with the recommendations they made this week, they may actually be on an improving trend. That trend will, of course, be dependent upon the precipitation over the next 3 or 4 weeks. But right now, it looks like they've stabilized, and we're not seeing continued degradations. We're actually seeing some improvements. At Colorado, they too look like the drought had the advantage for the last several weeks or months, and is now either stabilized and improving or just stabilized in Colorado. So both of those look better than they could. Next slide, please. In New Mexico, they've been bad for a while, and they've even dipped into the D4 areas. That being said, it looks like they're not getting worse, and they may actually be on a upward trend with regard to the drought. So the amount of drought in the state appears to be dropping a little bit, or at least stabilized, maybe dropping. In Utah, they actually look pretty good. Very little of the state is in D1. I don't see any D2 in there, and there's a significant portion that is abnormally dry, but they look pretty good, and they don't look to be increasing in their drought status or their drought intensity. So that's a good look for Utah. Next slide, please. Wyoming, harder to say. We're kind of split right now between the north and the south. The south is stabilized. The north seems to be degrading. So we may still be on the upward trend with regard to the amount of drought in the state. We'll see what happens over the next couple of weeks or next month or two. But right now it looks like we're moving into some degrading territory in the northern parts of the state. Southern part of the state, I think, is offsetting some of that increase. Next slide, please. Okay, this is the Colorado Basin River Forecast Center water supply webpage. They display data for the entire Mountain West. I've zoomed in here to the Intermountain West region, and these are all forecast points, and they are all color coded by the percent of normal for the current water supply forecast. I believe these are the official forecasts issued in the first of the month. As you can see, it looks pretty dreary, except for that band from Salt Lake City, the Salt Lake City area into central Colorado, where we're seeing a lot of greens, which means a relatively normal forecast. The oranges and yellows are not good news across the rest of the area. The blues are, of course, good news. Not too many of them, but they are out there, especially in the Bighorn Basin in Wyoming. So Arizona's looking pretty bleak with those red dots in the southeast part of the state, and the rest of it looks like it's in the below normal range. So those lots of oranges and lots of yellows in there. This is reflecting widespread snow deficits up until the first part of this first 2 weeks of February, when we got a good chunk of snow. The high country in Colorado and the Salt Lake City region look pretty good. The problem we're going to see is that the main state Colorado is still hurting. And I'll talk more about that here in a little bit. Next slide, please. This is the water supply forecast for inflow to Lake Powell and Glen Canyon Dam. As you can see, the blue line is the daily forecast. The pink dots along that blue line are the official monthly forecasts issued in the first of the month or the first part of the month. And as you can see, that blue line is well below the average. And we'd really like to see that well above average to put some water in the reservoirs or the downstream reservoirs. So this is the only water supply outlook I'm actually going to show, but you can see it's reflecting a lot of what's going on in the upper Colorado, and it affects all of the states, the Intermountain West. So however good it's looking upstream, downstream, we're not producing the water we need to start refilling the large reservoirs downstream. Next slide, please. Speaking of those reservoirs, these were very interesting patterns I was seeing. Both of these products are from the Bureau of Reclamation, and on the right it covers California, so we're out of the Intermountain West. But it showed very clearly Lake Powell and Lake Mead, the two in the lower left-hand corner, showing just how far below their conservation pools they are. On the left-hand side it shows the size of the reservoir and of the storage, and then it gives you a color coding of how that relates to the percent of normal. And it's a striking example. We had a good water year in the upper mountain or in the Wyoming area and in Colorado last year, and we put a lot of water into our reservoirs. A lot of our reservoirs in Wyoming are at conservation pool. They're at their design capacities. And that looks really great until you look at those two large circles in the lower left, which are Lake Powell and Lake Mead, and we have two massive reservoirs that are both well below their average storage at this time of year. So it looks great up in Wyoming for the most part, and it looks pretty good in Colorado. When you take it all the way to the end of the Colorado River, it doesn't look that great. Next slide, please. Kind of busy graphics here, but these are from the Bureau of Reclamation. These are their 24-month or 2-year models of storage in the two reservoirs. Lake Powell is on the left, Lake Mead is on the right. And that green line represents their most probable storage based on their modeling. Lake Powell doesn't look terrible. It shows a climb for the most part over the next 2 years. But if you jump over to Lake Mead, the climb in storage in Lake Powell reflects, as I'm going from someone else's interpretation here, but it shows the effect of the water supply in the upper mountain states, and it's showing all of the snow that we were just talking about and what they're expecting that to do for the lake over the next 2 years. Lake Mead, if you look at their green line, they're showing a wavering decline over the next 2 years, especially over the next year. And I asked about why we're seeing such striking differences in the relative position of their most probable data. And what I was told was Lake Mead, the model for Lake Mead reflects operations at Lake Powell more than it does the amount of snow available up in the mountains. So what's happening at Lake Powell directly affects Lake Mead and their ability to fill Lake Mead. Now, Lake Mead has seen some really nice increases in its elevation because of the atmospheric rivers that have been hitting California. That's kind of unexpected water that you don't normally expect to see filling the lake, but they got it, they're taking advantage of it, and they're putting some water into the lake. However, even with those recent inflows and the inflows last year, they're still expecting the lake level to decline over the next year and over the next 2 years. Next slide, please. Next slide. So now we're just going to take a look at the weather that we're expecting to see over the next several time periods and just get a feel for what we may expect over the next 3 months or so. So over the next 7 days, this is what we're showing here. It doesn't look great for northern Wyoming and those areas that have been hit hardest in the state. We're looking at decent accumulation in northern Utah and central Colorado. So kind of continuing that trend of that water supply trend that we've seen, that precipitation should translate into snow water equivalent up in the mountains, and that should be reflected in water supply. Arizona looks like they're doing okay as well, especially up in the Grand Canyon area. And New Mexico looks like they're going to miss out at least for the next 7 days. They may get some up in the Sangre de Cristos, but it doesn't look great for the rest of the state. Next slide, please. So looking out 1 month, these graphics are from the Climate Prediction Center, and they're showing gross trends in the signals that we get from the long-term data. We're going to be looking at 1 month and 3 month, and they just tell you which direction things seem to be leaning, whether there's an increased chance of above normal or below normal precipitation, or above normal and below normal temperatures. So in this case, you can see there's a moderate cool signal in southern Arizona and New Mexico, and it's surrounded by a weaker signal as well. So there's a signal there. There's very little signal in Utah and Colorado. Even that area of Colorado or Utah that's covered that's a relatively weak signal. So instead of having a 33% chance of above normal temperatures, you're looking at a 33 to 40% chance of above normal temperatures. So it's a signal. It's not a terribly strong signal. And that signal also covers most of Wyoming. So there's a weak warm signal in Utah and Wyoming, and Colorado has no signal at all. What that no signal means is that your best forecast is climatology. If we look at precipitation on the right-hand side, a little more to talk about there. We've got a below normal signal in southeastern New Mexico, but we have a fairly pronounced above normal signal in eastern, that's the higher area I'm talking about, the moderate, what I call a moderate signal in Wyoming and Colorado, and then the weaker signal, but still present signal, stretches across the rest of Colorado, the rest of Wyoming, Utah, and a good chunk of Arizona. So we're looking at above normal signals for a large portion of the Intermountain West. Next slide. Okay, if we jump out to the 3-month outlook, and you look at the temperature signal, there's a huge part of the Intermountain West that has equal chances of above normal, below normal, and normal temperatures. There's just a band of a weak signal for above normal temperatures in northern Utah, and then across a good chunk of Wyoming, and then a very tiny area of moderate signal up in the Yellowstone area. So not a lot of signal there in the temperature outlook. In the precipitation outlook, there's even less signal. So we're probably looking at climatology across that area, or at least that's what these maps are showing us. So there's a very weak or small signal from weak to moderate for below normal precipitation in Arizona and New Mexico. The rest of the Intermountain West, equal chances of above normal, below normal, and normal precipitation across this time period. Next slide, please. So jumping out to the seasonal drought outlook, this is actually a pretty decent looking outlook. It's from February through May, and it's pretty optimistic in Wyoming, Utah, and Colorado. The drought is going to persist in northern Colorado, and with those little patches, or northern Wyoming, excuse me, and in southern Colorado, and those little patches that we have there. But it's not showing the drought worsening, and that's pretty good news. The Arizona and New Mexico are both looking at drought persisting across large portions of the state. I would say most of New Mexico, or almost all of New Mexico, and most of Arizona. So it's decent news. It doesn't show the drought intensifying, but for Arizona and New Mexico, it doesn't show a lot of drought removal either. So that is what we've got there. So go ahead, next slide, please. You were right on time with that. I just didn't tell you. So in summary here, it has been dry and warm across most of the region this winter, and that created a snow deficit that has started to be alleviated somewhat during February. Until February, 1st of February, things were looking pretty dry. The drought conditions in the drought monitor may be slow to recover as the snowpack and runoff are assessed. At least for me personally, when I'm doing the drought monitor recommendations, it's hard for me to translate snow into drought relief until I've seen that snow turn into liquid water. It's kind of like money that's owed to me. Until that check hits the bank and clears, I don't count that as an asset just yet. So the snow is unrealized gains until we see that turn into water. The headwater reservoirs have recovered rather considerably from the long-term drought. However, Lake Mead and Lake Powell at the bottom of the Colorado remain extremely low, and they are forecast to stay that way. Climatologically, we're in a strong El Nino right now, and it is forecast to transition fairly rapidly into a La Nina. There's some issues with that in that there's a difficulty in translating for a forecast made at this time of year into the summer, because there's a blockage in the spring. So our climatologist tells me that really makes it difficult to make a good forecast across that barrier in the springtime. But in El Nino years, and especially in El Nino years where we transition rapidly to La Nina, that would be, I think, 1983, 1995, and 2010. Those years tend to bring late winter and early spring snows to at least Colorado and Wyoming. I didn't get a chance to look at the other 3 states, but those years were remarkable in how late the peak of our snow water equivalent was across Wyoming and Colorado, and in the amount that came, well above normal in all 3 years. That's not to say that's a forecast. That is simply looking at some potential analog years to this year and seeing what happened in that time period. So there is hope that we could see a late season snow accumulation, and it could be rather large, but I won't call that a forecast, and I won't even call it an outlook, just a potential for things that have happened in the past. And that's what I have for you.
Wow, thank you so much, Tony. Next, we are going to switch over to hear from Tony Bergantino, who is going to share with us about Wyoming's drought and water dashboard. So Tony, I'm going to make you a presenter. And then you can take it away.
Okay, let me share screen here. You able to see that?
We are. It looks great. Thank you.
Great. Well, thanks, Gretel. And as Tony said, it's afternoon, so good afternoon, everyone. I'm Tony Bergantino, Director of the Wyoming State Climate Office and the Water Resources Data System. And today I'm going to talk to you a little bit about our new Water and Climate Explorer, which was initially released back in October. And it actually just had a major version upgrade this week, so we'll talk a little bit about that. First, a customary little bit about us. Many of you are familiar with who we are, but for those of you who aren't, the State Climate Office, the Water Resources Data System serve citizens of Wyoming and surrounding areas by providing a source of climatological, hydrological data. We've been around officially since 1967, and we've coordinated the state's drought input to the U.S. Drought Monitor since 2000, and we're now very grateful for folks like Tony Anderson, who you just heard from, and others who are helping with the weekly recs. It gets to be pretty time consuming even at a state level, which makes us all appreciate even more, just how much those national authors are doing, taking that for the entire country and also herding the input from the 50 states. As part of that, and to serve the interests of Wyoming, we're involved in producing drought monitoring products, as well as serving water and climate data and publications online. We're funded through the Wyoming Water Development Office, and we're a part of the Department of Atmospheric Science at the University of Wyoming. And the presentation was billed as being our drought dashboard, but the Water and Climate Explorer goes well beyond just drought, and it sort of serves as a portal to many aspects of Wyoming's water and climate resources and data. Now, the original dashboard, which was for purposes of informing us on input into the U.S. Drought Monitor, began as a series of maps that I would produce a couple times a week showing precipitation percentiles and percents over various time steps from 7 days, I think it was out to about 6 months originally. Temperature and soil moisture were then added to the mix after a while, and well, I did have some scripts set up to generate the rasters themselves for the different time steps. The process was still run manually with each of the resulting rasters then put into a template so that you can export an image like you see here. And this obviously ate up a large chunk of my morning whenever I did that, and it limited the frequency at which these could be run, and then also the number of time steps that we could show, the 7-day, 14-day, 30-day, things like that. Once those maps were generated manually, the images were uploaded to a behind-the-scenes web page, and then subsequently others were able to look at the comparisons and make recommendations. And this slide here is part of a screen grab from the page showing the 60-day and 90-day precipitation as a percentile. It shows it for the present day on the right, and then 1 week ago on the left. And so you can easily see the change in 1 week, especially up here on the northern part of Wyoming, going from last week to this week. But let's leave the static map dashboard for a few slides and look at another method of displaying maps as we sort of evolve this, a more dynamic method. We've had a number of map servers through the years, starting with a really homegrown implementation that would take input from a user. It would read where the user clicked on an image or on buttons, and then from that kind of figure out what the user wanted to do, and then it would redraw and create a completely new image and send that out as a way of updating the user on what he had requested. And that was groundbreaking for 1997, but it was horrendously dreadful for 2024. So we upgraded that probably a little less than a decade later to another product. It's called ArcIMS, and then another decade later to that to an ArcGIS server. And now, in the meantime, I've been experimenting with some other mapping software and settled on OpenLayers. A few trial map servers have been developed back about 2018, 2019 for some small topic-specific data serving pages, and then work began on doing the same for our new Mesonet that we had launched. And the interface for that Mesonet is shown here. It's somewhat similar to what we're currently running, but it's evolved again. So with the creation of that map server, well, I was hit by the idea that maybe if I could upload the generated grids for precipitation, temperature, soil, have them display on the Mesonet map as an image overlay, then people could view them there. You'd be able to overlay, say, the drought monitor instead of having to eyeball where different boundaries are. But it wasn't too long after doing that one of those 3 a.m. ideas hit me, and that really resulted in several steps forward. The long story short of that is by running basically 2 operating systems on my desktop, I was able to create the grids, transfer them to the Windows side, and through some back and forth was able to automate pretty much the entire process of creating these maps. And soon if I was able to run that command automatically, it would run every day without me having to do anything other than make sure nothing broke or some data source wasn't missing. And this was a major leap forward, which freed up a lot of my time, which I then filled by increasing the number and types of maps that were put out there. And yeah, it would take longer to generate, but at least I wasn't doing it by hand. So the first thing to do is to increase the time frames. Now these maps can be run for 7, 14, 30, 60, 90 days, 4 months, 6 months, 9 months, 1, 2, 3 years. I could do precipitation, percent of average, percentiles, departure from normal, max, mean, min temperatures, and a host of others. And Montana was also generating some excellent SPI, SPEI, the Standard Precipitation Index maps, and was able to produce a Wyoming-specific image from that. So we were able to put those up there as well. And the no risk that Tony mentioned for snow water equivalent and depth, we were able to add those and do comparisons on those parameters. And all of this was put out on one long web page that I sort of showed that one little example with the 60 and 90 day before. And the next little step was for Mondays, making a little tweak to the script, and it would automatically generate a PDF of all that and distribute it to the conditions monitoring team in Wyoming for coming up with recommendations for the drought monitor. But last year, I turned my attention back to the map server with the thought of being able to incorporate all those layers, as I'd mentioned, so that you could bring up the percentiles, compare them, say, with veg dry, soils, put the drought monitor on top of that, or zoom into an area, look at snow water equivalent. Sky was pretty much the limit. So The Mesonet map server was torn down and rebuilt. I didn't like the canned table of contents that was in it. It was pretty clunky and inefficient. So that was rewritten to accommodate our growing list of contents. And functionality was added to display legends, adjust transparency, label features, refresh with current data, query a layer to retrieve numeric data. And don't really have near enough time to go through all that in detail or to give justice to the contents, but I'll instead just show some of the features and then invite everybody who's listening to try it at your own leisure and provide whatever feedback you can. So we'll start out with the obvious one, the US Drought Monitor. And while the Explorer is definitely a Wyoming emphasis, many of the data products that I draw upon to create some of the derivative layers are, well, they're nationwide. So you'll find many things in it that do not stop at our borders. USDM is just one of those. And I have the map centered here on the Intermountain West, which I figured would be kind of appropriate for this audience. So you can see that it's not just limited to Wyoming, but where available, we do have some of these products going across the country. And this one, I've turned on the precipitation percentiles layer, and I kicked up the opacity of the drought monitor. With this view, we can look at areas not in drought and see how, in this case, the last 60 days were. Across the top, you can see buttons to change the time frame from 7 days out to 3 years there on the right. By adjusting the transparency of the drought monitor map or by toggling it on and off, you can see what areas may be ready for improvement or which ones need to be degraded further. So instead of eyeballing an area and trying to superimpose where the drought lines were, you could just overlay them. Where the dashboard of static maps is nice, though, is being able to compare a previous time period, that last week versus this week comparison that I showed on that other slide. But a little bit more on that later. Now, the hazards of it's going to run. So by either turning off and on the US Drought Monitor layer or by sliding that transparency bar up there circled in red, you can blink a layer on and off to see what the conditions are underneath. But say it's winter and you just want to look at snow water equivalent specifically. So, well, we have the snow water equivalent shown here. Tony did show this in his slide. This again comes from NORISC, but we've added a few additional features that I'll go into here that you can do with it. Say you'd like to query a specific spot, you activate the layer, click the map. I chose a spot inside this yellow little rectangle up here in the Tetons, and to the day, the value for that spot was 26.73 inches of SWE, which you can see in that little pop-up box over there and highlighted in green in the upper left. What's the departure from normal or median? You can show two maps side by side, or you can do as I've done here, and I subtract the last week's grid or the 2 days grid from there. Actually, this is median, so actually we're subtracting this from median. You can do other time steps as well. So this shows the median SWE for the 18th subtracted from today's value, and you can see there's some good areas where it's better, and you can see some areas where it's not as good. And we seem to be stuck.
Tony, perhaps in the interest of time, we can, since it's stuck, we might want to move on to Kelley's presentation if you want to give us a quick summary.
Okay. Why don't we just hop over to her? Okay, there we go. All right, so we'll skip through. There's the 2-day comparison. And then you can jump in and look at some of our Mesonet data, bring up dashboards of it, get in there further. And last thing I want to touch on is the mobile aspect of this, and it does work on mobile quite well, if I do say so myself. And here's just a few examples of mobile screens where you can view the various things on there on your phone. And quick little thing here that's ever evolving. We need your feedback. What would you like to see in there? If you've got suggestions, I've got a number of them so far. Just keep them coming. And we'll call it good from there. So thanks for listening, and I'll pass it back to you, Gretel.
Thank you so much, Tony. That is such an informative and very cool product you guys have there. So thank you so much for sharing. And next, we will hear from Wendy Kelley. Wendy, I am going to make you the presenter, and then you can share your screen.
Okay, I'm watching for the option to share my screen while Gretel does that. For the sake of time, I'll run through my presentation more rapidly, but Gretel invited me to talk about some work that we're doing here in Wyoming. It's a needs assessment of information, data, tools, resource needs about weather, climate, and water availability of Wyoming's agricultural and rural communities. And just to quickly go through these, Wyoming, similar to other places, has experienced a lot of changes, seeing an increase in temperatures, changes in our precipitation, an increase in heavy downpour events since 1950, among other changes. And as we see these, we realize the value and importance of getting this information to agricultural producers and other working land managers in a timely way so that they're using science-based information to make more informed decisions. That being said, some work was done a number of years ago, a handful of years ago, the USDA, NRCS, and FSA employees that showed that field staff are interested in using weather and climate information and forecasts in their work, but they have a low confidence in their ability to do so. And this really makes sense when you think about it, because many of them go to university and get formal training in cropping systems, working with livestock or rangelands. However, a lot of those programs do not integrate meteorology or climatology into the programs, although those are variables that influence the success, oftentimes, of our agricultural communities. So taking this research in mind, as well as kind of narrowing into and focusing on Wyoming and the situation within Wyoming, which based on observations and other just kind of qualitatively noting that we have a high turnover of agency employees in the last number of years due to retirement and other reasons. And a lot of the new hires appear to be from out of state, oftentimes not from semi-arid communities or states, that there was a need to kind of get some information out to them as well and working in these systems. Many technical service providers also that have been working and living in Wyoming for many of years, they don't have the training to talk about weather and climate as noted before. And so they're more reluctant to integrate that information into their programming and into conversations with the agricultural producers. So we decided to go do a needs assessment. And the goal of the needs assessment is to identify weather, climate, and water data, tool, and resource needs among technical service providers that would enable them to better serve their clientele. And the funding for this was provided by the University of Wyoming Agricultural Experiment Station. And again, the target audience are technical service providers that serve agricultural and rural communities in Wyoming. We did a series of focus groups, which are relatively small groups of about 10 invited participants. We asked them the same set of questions in each of the focus groups with some variation with follow-up questions as needed. And this is all approved by the University of Wyoming's Institutional Review Board, or IRB, to work with human subjects so that we can publish our results. We've completed we're going to do 6 focus groups total with technical service providers throughout Wyoming. We've completed 4 so far, so June of 23 through January of 24. We have 2 more to do. 3 of those have been in person. 1 was virtual due to weather and road conditions. We've had a total of 36 participants representing USDA, FSA, NRCS, among other USDA agencies, DOI, BLM, a number of extension professionals, as well as employees from multiple conservation districts throughout Wyoming, state agencies, land trusts, and private organizations, again, that work with agricultural communities and our more rural communities. I won't go into the data analysis, but we are in the process of analyzing the qualitative data and developing 2-page summaries for each of the focus groups that we'll then send back out to the participants for kind of a validation and review that we did capture this correctly. If they have any additional input that they want to provide, they'll have the opportunity to do that. We'll then aggregate all the results across the focus groups, write a final summary, and we'll be able to publish those findings. So the preliminary results, and I'm not going to, there's a series of slides after this, but for the sake of time, the kind of initial results from the first 3 focus groups. So we've had a total of 4 focus groups, but we've only analyzed data from the first 3. Some of the key needs that have risen to the top include interpreting the data, climate and weather data more, and so that it's more accessible and usable for them to integrate into their programming and conversations. Another key finding that in our preliminary results is a need to provide information as well as develop skills as it relates to climate communication. So folks, you know, they don't have that terminology, they don't have the formal training, or even how to talk about climate because it can be so not a comfortable topic to bring up sometimes with folks. And so how to do that and developing that skill set. So there was a number of other really interesting preliminary results, and hopefully there's an opportunity to present our final results to all of you once we pull those together and have them available. Our next steps I want to make note of is to complete those focus groups that we haven't done yet with the technical service providers, finalizing the data sets, and then being able to publish them. But looking further out from that, we did apply for a USDA NIFA Extension Climate Hub grant, and we're waiting for a public announcement on those funding. And within our grant proposal, we did propose to do another set of focus groups that would be with agricultural producers themselves, so doing a similar needs assessment. And then we could draw upon the findings of the 2 different needs assessments, the technical service providers and the agricultural producers, to help inform the additional aspects of the grant and what the grant would entail. So with that, Gretel, I'll just skip to the very last slide with my contact information. And I also want to, as I do that, pause and thank the technical service providers, our funding through the AES, our local hosts and partners, and members of my project team. Thanks, Gretel.
Thank you so much. Thank all of you, both Tonys and Wendy. This has been an incredible multiple presentations on all of the amazing things that you guys are doing up there in Wyoming, as well as a great overview of what's happening across the Intermountain West in terms of drought, snow drought, and what's to come in terms of outlooks for water supply in our reservoirs. Let's see. And so I'm going to end this webinar. Please keep an eye out for the recording, which is located on drought.gov/webinars. And if you put questions in the chat, I will forward those along to our presenters, specifically due to our time limit here. But we very much thank you so much for coming, and we hope to see you next time.